All right, this video is about polar coordinates and how do you graph them, how do you connect them to what we already know. So let's talk about what polar coordinates even means, okay? So here's a couple definitions. The origin is a fixed point or zero called the pole. Now, polar graphs just look like a big target, okay? So you start with your basic grid, and it's just concentric circles, okay? No, they're not perfect, but they're circles. Okay, so at 0, 0, that is the pole, and then we measure the radii from the pole. So at 1 circle, that's 1 radius. At 2 circles, it's 2 radius. At 3 circles, it's 3 radius, and so forth. So you'll see in your point, the first number you get is the radius. How many radii out is it? And theta is the angle from the pole, and we use basically the angles from the unit circle. So here's 0, here's pi over 2, here's pi, here's 3 pi over 2, and then the full circle is 2 pi. So you will reference your unit circle to find your theta value. And you'll just want to locate it in the right quadrant. Okay? So you're going to be doing a couple things. You're going to graph the polar point, and then you're going to convert it to a coterminal name of the same thing. I'm going to show you how to do that. It's not bad. Here we go. So here's your first example. Graph the point coordinate, give 2 additional names for the same coordinate. Okay, so when you graph this, notice there's a 3 for the radius. So here's my circle, and I need to do 3 circles because 3 is my radius. So I go 1, 2, 3. And then pi over 3, if you look on your unit circle, pi over 3 falls within the first quadrant. So I'm going to put my point on the 3rd radius out and connect it up like that because pi over 3 falls within the first quadrant. So I've graphed my point. Now, to get my additional names, the first thing I'm going to do is take my original point and I'm going to add or subtract 2 pi. Now I'm going to show you how to do that really easy. So if pi over 3 is right here, you can add 2 pi, do the whole fraction thing, or you can just subtract. And subtract just means we're going to go the opposite direction. So here's the way we work that. Okay, if you remember way back when we talked about negative angles, we would take our original angle and flip it over the x-axis. And where it landed, this one, like at pi over 3, flips over and it lands on 5 pi over 3. And the only thing we do to change that is make it negative because we flipped it over the x-axis. So there's my new angle. So my first additional name is 3. It stayed the same. And the angle is negative 5 pi over 3. Done. Now for the second additional name, there's 2 things you got to do. First, you change the sign of r. So r is no longer positive. I'm going to make it negative. And add pi to theta. So here's a real easy way to do that. If pi over 3 is right here, to add pi means I back it up 180 degrees. So let's think about what pi over 3 angle is down here in quadrant 3. Well, if you look at your unit circle, that's 4 pi over 3. And that is what I get when I add pi. So I get 4 pi over 3, and there's my second name for that polar coordinate. Okay, let's try another one. Okay. This time, look, our radius is negative and our angle is theta. So my radius is negative. I'll show you how to handle that. It's still 2 circles, so I'm still going to draw 2 circles. And my point's going to go on the second circle. Now, pi over 6, if you look at your unit circle, that is in the first quadrant. Now, before I put my point there, I have to account for the negative radius. Negative radius means I back it up 180 degrees. So if I was going to be here, I back it up 180, and it goes right here. Okay? That's how I graph. You just back it up 180. So now to find my 2 additional names. So if you recall, what did we do on this one? We leave radius alone, and we take our pi over 6 angle, and we flip it over the x-axis and make, so my angle is a negative 11 pi over 6. Okay, there's my first new name. Now the second one, we start by changing the sign of r. So r was originally negative, so I'm going to make it positive. And then let's think, pi over 6 is here. If I back it up 180, what pi over 6 angle is over here? Well, that's 7 pi over 6. So my angle is 7 pi over 6. There it is. Let's try another one. All right. So when the angle, you got 2 things going on. You've got a square root for radius and a decimal for radian. So let's just think about this. Square root for 2, if you put that in your calculator, you get 1.41. So think of it as negative 1.41. And with the negative 2.54, okay, let's figure this out. If you recall, way back when we first started radians, we said that 3.14 is the same as pi. And we split that in half and we got 1.57. And then this is 4.71, and this is 0 or 6.28 pi. It's 2 pi's. So 2.54 falls over here in quadrant 2. Square root of 2 is 1.41, so that's between a 1 and a 2. So I'm going to draw 2 radii, but I'm not going to put my point on the 1 or the 2 because it's between the 2 points. All right? So 2.54 falls in quadrant 2. However, the radius is negative, so I got to back it up 180 degrees and put it here, going this direction. Okay? So there's my graph. Now, to add or subtract 2 pi. With this one, I would just think of 2 pi as 6.28. All right? And over here, when we add pi, I would think of it as 3.14. So let's just leave our radius alone for this first one. So it's negative square root of 2. And I would take my 2.54 and add 6.28. It's harder to flip over the axis when it's a decimal, but we can handle this. 8. Okay, so my angle is 8.82. That'll work. Over here, we change the sign of r, so now it's going to be a positive square root of 2. And I take the 2.54 and I'm going to add 3.14. So 5.68. There you go. All right, so it's not too bad. You just got to pay attention to the details. Last one. Negative 10 and negative 1.57. Okay, so I don't want to draw 10 circles. Do you want to draw 10 circles? Heck no. So you can scale your circle. Scale your circles as needed. So I'm going to just do 2 for space, but here's what I mean by scale it. I need to label it. So this is going to be 5 and this is going to be 10. You could go 2, 4, 6, 8, 10. However you want to scale it, you just need to label correctly. Now, 1.57. Okay, let's label our decimals. 3.14, 1.57. So when we have negative angles, remember we're going this direction. This is negative 1.57. This is negative 3.14, negative 4.71, negative 6.28. That's what negative angles means. So at negative 1.57, that's right here. But then the 10 is negative, so I have to back it up 180 degrees. So that puts it right up here. Okay? I always do the negative angle first and then the negative radius, right? Now, to rename it, I'm going to add or subtract 2 pi. Well, 2 pi is 6.28, right? So I'm going to leave the radius alone for the first one. And 6.28 minus 1.57 gives me 4.71. So there's 1. And this time, I'm going to take the negative 1.57 and I'm going to add pi, which is 3.14. And that gives me a positive 1.57. So to get my point, I'm going to change the sign of r, which makes it positive this time. And my new angle is 1.57. Okay? So I've shown you 2 different ways, or several different ways to handle the angles with decimals or with just regular radian angles to find your coterminal names for these polar points. Hopefully that makes sense. And we will see you in class.